Before I introduce my next speaker, I need to announce that we have a new version of the agenda. You can collect it from outside. It is not that up to date, but at least it will reflect part of the agenda because of the logistics that we have. People did not show up due to visa issues or something like that. So we had to keep changing the agenda so we can save as much time as we can, and we be able to keep you busy the whole morning. My next speaker is Mr. Islam Abou. Sorry for the delay.
Good morning, everybody. I'm really sorry for this delay. I think when it comes to technology, sometimes it always happens. So I'm going to take you away from to something else, Earth observation, and I'll tell you how much this Earth observation is the top agenda for the Arab region and Africa, and how much this Earth observation could contribute to the socio-economic development. My name is Islam Abou. I'm from the National Authority for Remote Sensing and Space Sciences, which is dedicated to, it's a governmental research institute dedicated to remote sensing and space technology. Actually, my presentation is going to talk about SDGs, and it's a global agenda, and how much Egypt is focused on the 2030 agenda for socio-economic development. And underneath this socio-economic agenda, how much this kind of Earth observation could contribute to this agenda. The two main pillars for the socio-economic development of 2030 agenda is socio and economy. How is the social development being happened to the community, and how economic at the same time. But you have to sustain and conserve the environment and the natural resources management for the new generation. So there's a lot of mega projects, good projects, a lot of activities being mentioned, a lot of strategies, a lot of roadmaps, all this kind of about how to, by 2030, to reach to a point of development of social and economic. But how can you get the right information, the right data, the right decisions to achieve this kind of agenda? So, at the end of the day, they realize that there is a tool, global or worldwide, that could contribute to this kind of information on a real time or near real time, which is the Earth observation, that could support the decision makers and policy makers and planners to get the right information at the right time. So if you look to the data, I think this is not the last version, but anyway, the natural resources, you got land, atmosphere, and ocean that could contribute to the whole resources and economy. You would need to get into a model and integration of the data that bring to you to the sustainable development agenda. So the Earth observation is a kind of delivering this kind of information. If we look at the land use, land cover, and how much existing on Earth, in Egypt or whatever country, you need a kind of tool that updates this land use and cover on a yearly basis or less than a yearly basis. So if you got agriculture, you got urban, road infrastructures, industrial, all these kind of activities, how to provide the decision makers this kind of data into a real time or near real time on a regular time basis. If you look how much dense is this kind of data, if you look to the screen, it's not just a colorly picture, but if you go on Earth, it's quite difficult and hard to get exactly this kind of information. The food security and how much being for two cash crops, rice and wheat. How can you estimate how much area being planted for cash crops and how much you plan to get the yield of these crops to plan ahead how much deficit you need to get into the economy. So there's a lot of activities and models to use this kind of data to identify exactly what yield. I'm really sad that this presentation is not the last version, because there's a lot of changes here. I sent you this preliminary one to keep my slot, but I think there is a lot of missed slides here. In this particular slide, there is a model that shows you how can you forecast for the yield of the cash crops. This forecasting of yield to know how much you need for the deficit, for the requirement of the community. Other urban growth, or how much urban being developed onto the agricultural land, and that create a problem into the agricultural land. So Earth observation could monitor in a time series analysis to identify exactly what kind of urban growth on the agricultural land, and which direction, and which kind of catalyst parameters that enable the farmers or the local community to develop their urban in a direction rather than the other. All this kind of time series or real time could come from the Earth observation. Climate change and heat islands, how much is the population density, the industrial activities, the traffic jams, all this kind, how much to contribute to the heat islands and change in air quality. All this kind of data could be gathered and analyzed and being generated as a services from Earth observation. So this kind, you can compare even between the populated areas, cities, and the rural areas, and how much difference for the heat advection and convection between these kind of communities. So land surface, land albedo, all this surface you can generate it on a daily basis, like the weather forecast, on a regional basis for Northern Africa and Arab region. All this kind of data, you can't get it automatically and real time or near real time on a regional basis from Earth observation. You can model this one to see how much is the point sources and how it goes, how it moves into the community. For the dust storms and the BM 2.5 and BM 10, and how much it creates on the chest problem and create health, chronic disease for the children. So you can monitor these dust storms and particle matters and see where is the sources. Coastal lakes and coastal resources for the fish stock. So you can identify the boundaries, the ecology of the lakes or the freshwater system, the fish stock in this one, the algal blooms. All this kind of data could be get from Earth observation for the area. And even advise the policymakers to what kind of activities on development you can do on the coast to monitor the resources and to get against any hazard, natural hazard, like tsunamis, like earthquakes, like sea level rise, all this kind of data. So again, Earth observation could provide the planning for the new cities and how much resources underneath the ground and above the ground, and then how much resources you can help decision makers to use for this particular land for new cities. Hazards and coastal erosion, and how much you can monitor in a yearly basis or a time series basis, how much area being eroded and how much area being smoothed and deposited. All these time series of satellite data again you can use. Before I end, I would like just to flag the point here that this kind of technology, it needs to be promoted in the Arab region and Africa. I know that there is some Arab countries ahead, but few steps ahead, but we need to see how can we engage all the Arab countries into one community for the Earth observation. We do have a satellite, we do have receiving stations, we do have our own infrastructures. There is Algeria, they do have their own. Other Arab countries, United Arab Emirates. How can we engage all these Arab countries into a forum for Earth observation and satellite technology? Thank you very much.
We have a time for one or two questions. Any question? Are you allowed to ask?
Islam, thank you very much, and sorry that the slides that you have sent were You sent us a new version which wasn't uploaded to that. So very sorry. Can we share that these slides presentation with our colleagues?
No problem at all.
So this is thank you. We are coordinating with the NARSS with the STAM specifically for the FGO's activities, and we are part of the GDU working on FGO's Earth observation for Africa. Also, we look forward to have something like not similar GEOS, but at least to have a community that takes care of the Earth observation for our region. As you saw, I think this presentation is going to be a keynote, not only just. It's really very important for all of us to take care of the, when we want to have, to take a decision, to take into consideration the Earth observation that can help us a lot in our decisions. So it's not a question, but commenting on what we have presented. Thank you.
Thank you, Yusuf. No problem at all. I would like just, I'm not blaming you, I'm blaming myself, but I did follow the instructions. I sent you the presentation via the internet. I thought everything's secured and everything is under control. Anyway, no problem. I like the idea that you mentioned that about Arab JS. Why not? There is Europe JS, North American JS, or Latin American JS. Why not to make it, instead of Afri JS for Africa, another one, Arab GS for Arab countries. GS is the Global Earth Observation System of Systems, such a global system. How can you plug into a regional system, just plugged into for the regional problems, regional resources, regional networking, all the Arab regional? I like, you can get this one and we can talk together about it. Thank you very much again.
Thank you very much, Dr. Islam. Mr. Mohamed Yasser Khalil from SESAME.
Okay, as I was told right now, I have 12 minutes, which I'll try to make in 12 minutes. I'm just introducing to you SESAME. What's SESAME? And I heard the name SESAME yesterday, but not too many times. For some of our audience, we don't know what is SESAME, so I'm going to introduce that very quickly. SESAME is simply a multinational light source built in Jordan with membership of 8 of the countries in the region. Let's start with light sources. We have about 70 light sources in the world, most of them, or almost all of them in the developed countries, about 9 in the United States, some in Europe, many in Japan, and but some other developing countries also. If we consider Brazil, for example, developing country, we have light source in Brazil. We have one light source in Thailand. There is another light source, I think, in Korea. So we have in other places, but none in our area, none in the Middle East, none in the large Middle East, as we can. So SESAME, which is there, is the first one. I think this one is working. Oh, yes. SESAME, which is here, is the first light source in the region. These are the members of SESAME. We have 8 members: Turkey, Cyprus, Jordan, Israel, Palestinian Authority, Egypt, Iran, and Pakistan. Some people consider that strange combination, but we have also observers, which is almost most of the developed countries, starting with Brazil, Canada, China, up to 17 countries, including EU, and CERN also has become a member, an observer of SESAME in the past few months. Sorry. Okay, here is where SESAME exactly. SESAME is in Jordan, and it's very close to the border between Jordan and West Bank. SESAME is a 3rd generation light source, which means it's more developed than 2nd generations in many aspects. But the purpose of building SESAME was to foster excellent science in the region. It's modeled on CERN, so we're trying to do to the region what CERN did to Europe. It states the standard of scientific research in the area, which we're trying to do that, and also building bridge between diverse societies. Of course, we can see that. The only difference between SESAME and CERN was, despite the size, of course, is when CERN was built, there was no war anymore in Europe, and Europeans discovered that they have to live together. This fact has not been discovered yet in the Middle East, but other than that, we are similar in many aspects. We don't need to know much about the history, but the starting point of SESAME actually, practically, was a tent in Sinai, in Dahab, actually, between two scientists, Rabinovich from Israel, and Venice Gouda, which was the Minister of Scientific Research in Egypt at that time. Then things developed later, and we are here now. Why do we need to build the light source, not any other scientific research center? It's very simple, because international cooperation between countries which have small scientific research budget is very important. SESAME also has a broad program which allows scientists from many disciplines to come to SESAME for doing research. We hope that SESAME will be a place where scientists meet each other, and that will pave the way for further cooperation between the countries in the area. We don't need to know how synchronous radiation are produced, but they are very simply produced, in our case, by accelerating electrons in magnetic field. So when electrons are accelerated in the magnetic field, they emit radiation. This radiation, it goes in a forward direction as a cone. As more speed of the electrons, you get more of this radiation. Electrons speed in synchrotron systems are about 0.995 C, so they are almost running at the speed of light. So that's what causes the radiation to be emitted when they bend in dipole magnet. There are so many uses of synchrotron radiation. Within the 12 minutes, I cannot say it all, but I can say they are, synchrotron radiation can be used in, simply, you can see things down to the cell size and atom size. So you can see what's happening in real time sometimes. And you can apply that to all kinds of research in physics, in nanotechnology, in archaeology, in biology, in medicine, you name it. As long as you want to see what's happening at the same in a material, you can see environmental studies, of course, you can do a lot of analysis using synchrotron radiation. This I have already mentioned, so we don't have to go through it. This is a structure of a light source. This is a generic structure for light source. But usually electrons start here, which is, this is a linac in this case, sometimes it's a microtron, which you produce electrons, in our case at 20 MeV. Then it goes to a booster, and the booster raises the energy of the electrons to 800 mega electron volt in our case. Then the electrons are fed as bunches of electrons, of course, to the what we call the storage ring. In the storage ring, the energy goes up to 2.5 giga electron volt. In our case, 2500 mega electron volt. And when they are raised, the energy is raised to 2.5 giga electron volt. The electrons are bending magnets. You can see here all these red magnets are dipole magnets, when the electrons go in the dipole magnets, they bend. When they bend, they emit tangentially synchronous radiation. Synchronous radiation, when they go out here, they go to something called beamline. The question I'm asking sometimes at the end is, what is a beamline? A beamline is a set of devices that concentrate and focuses the electrons from certain wavelengths. It selects the wavelengths. It might be IR, might be ultraviolet, might be X-ray, and the electrons which go here, the photons which go here, synchronous radiation, are photons with wide spectrum from IR to hard X-ray. The wavelengths which we select, this device selects the wavelengths, and then the photons fall on the sample, and the data is collected and analyzed here. All this happens in this area, which is called the beamline. We don't have to explain how this is working. This is what we call the wiggler. A wiggler is a different device, but it emits 3 minutes. Okay, it emits electrons at photons at much higher concentration. By the way, the intensity of the photons coming out, brilliance actually of the photons which is coming out of the synchrotron source is about maybe 1 million times the brilliance of the sun. So it's a very, very, very concentrated. Okay, this is how SESAME looks like, layout of SESAME. This is a schematic of SESAME. Then how were things built at SESAME. Now this is where we stand. That's how inside the tunnel, we have all this equipment are built inside the tunnel of concrete, which is about 1 meter thick, to enable protecting the environment from electron radiations which might come out. Okay, storage, we don't have to need that. This is, okay. We have in phase 1 7 beam lines, XRF beam line and IR beam line. Then next year we will have a material science beam line, and by the beginning of 2019, we will have a protein crystallography beam line. Later on, we will have another 3 beam lines: soft X-ray, small and wide angle extreme. Okay, this is how the beam line looks from the inside. These are some of our researchers working on IR beam line, but it was working with a light with external source at that time. Okay, SESAME will be the first light source in the world to run totally on solar energy. By the middle of next year, 2018, we will have, this is 1 minute, okay. By the middle of 2018, we will have something like 6 megawatt solar power plant, which will supply the total energy of SESAME for the whole year. Okay, this is the important part. If you want me to skip this, I can skip. This is okay. This tells us how SESAME is connected to your actually meeting. SESAME is producer of big amount of data through one of the 2 beam lines, the protein crystallography beam line and the tomography beam line. Both produced huge amount of data. This amount of data, one experiment will produce, for example, 2 to 3 terabytes of data. And if we consider that Instagram the whole day produced 33 terabytes, so that means it's a lot of data that SESAME produces. A single image will have from either of these 2 beam lines will have about 40 gigabyte. Data transfer rate is about 512 megabyte or 1 gigabyte per second. I can skip that. Then big data generation solution is to have connection to supercomputers like the one we have now in Cyprus, which was built by funds from the EU. Other network has very good connection to SESAME, and they're providing a SESAME connection to Europe at the moment, and we are trying to increase our connection speed. This already has been mentioned by other colleagues. This is not important, but it just underlines the importance of the help SESAME got from the EU. We actually got a lot of technological, economical help from the EU to build SESAME. I can stop here. Thank you very much.
Thank you very much, Dr. Mohammad. So we'll skip to the next presenter, but we'll extend the coffee break for another 15 minutes. So we have time to drink more coffee, and so I call to the podium Ms. Elisabetta Zuanelli. I hope I read your name or pronounced your name correctly. Otherwise, I'm ready for any punishment. It's here.
Well, after this, good morning, this impressive presentation, and I shrink in my little bones, so I'll try to make my best. Well, talking about infrastructures and services, infrastructures and services, what I thought might be useful is to talk about the attacks, cyber attacks against cybersecurity of infrastructures. As you know, this is a big theme which has recently developed fastly, and I speak to you in my capacity as the coordinator of the National Plan for Training and Education on Cybersecurity, Cyber Threat and Data Protection, which at present is also the object of interest of the European Union. As you possibly know, there are two laws, recent laws, that will be operative since 2018. They have to do with the obligation, the compliance by institutions and companies, especially what we call the critical infrastructures, to comply with a number of activities in order to protect critical infrastructures and the activities of the member states, but also of companies working outside the state, the European states. So my presentation has to do with the product we have realized. It is the first example of a technological solution, namely a technological platform, which we call the POC, which was developed in order to start to work for protection, namely defense, and also the solution of cybersecurity problems. First of all, I would like to go back to a preliminary definition. As you possibly know, an ontology is a knowledge representation both at a formal abstract level and at the applicational level, namely at the domain level of knowledge. And knowledge is also used in order to release services. So this platform that I will present briefly because the time is not so much, has realized the first example. Just to let you know what we're talking about, many of you perhaps know what the United States have done in this perspective. The first ontology on cybersecurity is the vulnerability ontology that was released last September by NIST. NIST, as you know, is National Institute for Standards in Technology, American. They have started to work on ontology since 2010. They've done a fantastic amount of work trying to classify, namely to have taxonomies of attacks, of malware, topology, and things like that. But the only product is this one, this Vulnerability Ontology 2016. As far as Europe is concerned, you possibly know that Europe, through the Agency for Cybersecurity, ENISA, they have worked a lot by comparing the activity and the contents of CERTs and CERTs. These are the team, national and international teams that work for cybersecurity analytics. The synthesis of all this, and I will start with the presentation, has to do with the fact that when we talk about big data analytics for cybersecurity, we must have both formal level ontologies and application ontologies. And we need also to wonder why we have an ontology, besides the taste of the knowledge. And the answer is in the fact that if you want to have analytics, you must have an ontology classification, ontological model. Otherwise, data are no use. So big data analytics so far, even by companies that sell sort of technologies for analytics, are no use. You can have Hadoop, you can have Oxide. These are technologies that are no use unless you have an architecture. So that's why I propose this analysis, and I hope you, if you're interested, of course, the platform is online, it's working, it's already operative, it's not a project. So let me start. I don't know if I can move correctly. No. So, as I mentioned before, the situation is sort of Babel. People working on cybersecurity analytics speak different languages. And so it's impossible. Elisa has revealed last year there is no homologation in the way different institutions classify cyber attacks, cyber events, malware, and things like that. So what I was saying, the fact that everyone is collecting data in a different language. There are multiple standards. Of course, the USA, through the MITRE Corporation, has elaborated a number of open, say, databases, but the situation is rather difficult because there is no homologation among different proposals. Same wording are used for different concepts. So at a formal conceptual level, there is no, so far there has been no integration. And same concepts are associated with different categories. So what they call taxonomies are no really taxonomies. There are no classifications at all. That's a bunch of criteria that have been put together, but there are no classifications. Sorry. So what I present is this, we could call it a tool to normalize the input big data, namely to have a single language when gathering data, and data, of course, must be related to the ontology. As far as the approach is concerned, you are familiar with the idea that the so-called middle art approach starts from the idea that we must have a benefit from different sources. So when we study these things, we get the best that we can from different sources of knowledge, and we try to redefine them according to a formal level of definition. Therefore, we have developed an upper ontology and a mid-level ontology. You will see how they are composed. And the addition, this is the first time a functional pragmatic ontology is added to the formal level ontology. These are the concepts. I'm sure I'm not time enough to explain that these models come from semantic memory theories, say, dating from the 60s in the United States, from cognitive and say linguistic, cognitive, psychological approaches. So the definition of the formal upper level concept is very important. And briefly, I can simply list them. Entities, they are conceptual knowledge reference. Then we have added situational contextual relations, namely data is related, must be interpreted according to a number of links, conceptual links, otherwise it is no use. Agents, namely intentional and unintentional entities that cause actions. State, namely the state with where attributes and properties comply with entities. Acts that are de facto as minimal components of stages of events. Of course, we're talking about then cybersecurity events. Events that are changes of state in the focus entities. Attributes, properties. Focuses objects of actions and answer view, namely what are the motivations, whether they are intentional or non-intentional for action. Oh my. A mid-level ontology is added. This is normally used, time, which has to do with the initial and end state of an action, and place, physical or virtual localization. What is a pragmatic ontology? It is a knowledge representation of physical and virtual applications of the domain ontology. Namely, we can do conceptual operational schemas, I mean, from the theoretical to the practical application. Ontology meta-languages, which are awfully needed for having interoperability among databases, and software applications, such as the one that are promised by companies. Everybody promises a predictive approach, but if you don't have a conceptual framework to do that, I mean, it's no use. You can sell libraries, virtual libraries, they are no use. You have to define them. So what are the features that I consider useful for this development we have done? The univocal application of the representation concepts, entities and relations, namely in the ontology. The constituents, they are cybersecurity domain ontology, a cybersecurity pragmatic ontology, namely the application, cybersecurity knowledge, and a semantic vocabulary, which should be unambiguous, unequivocal. We have to understand with each other, otherwise it's no use to have data. And different level entities, which are connected by semantic and pragmatic relations. So this is the logical intersection. So this more or less is the representation of the fact that the ontology works with a number of both hierarchical and non-hierarchical relations at different levels. So this is, say, the effort. So as I say, the main ontology is univocal, it should be unequivocal. Structure has to do with preliminary taxonomies we have analyzed that have been realized in different parts of the world, namely in the States mainly and in Europe. I mean, we have tried to check whether it works and why they didn't work. We have defined hierarchical relations from broader to detailed, and then reticular multiple relations that make up. This is a screenshot of our platform. If you're interested, we might connect. I mean, it's online, so of course not open to everybody, but we can have access if you're interested in. So it's a single access point. As I said, it's good because it is theoretically based at a high level, but it's also useful for non-technical people. And they have, the platform gives a number of operative contributions, instructions, planning tools, gathering information, ontology, of course, correlating. So I would say that one would think which is important, if, say, a CIO of a company has to check the ongoing trends of cybersecurity of his company, say an energy company, as we have the problem in Europe nowadays, too many are there through, what does he do? How can he understand what's going on? Because there is sort of fracture between the higher level people and the lower, even technical people. So the platform allows us, since it is also natural language realized, it allows for this kind of relation. So, briefly, and I'll come to the conclusion, we have 7 analytic areas for cybersecurity services. That's what yesterday I tried to explain to a colleague of mine at this conference. So we have a tools area for risk assessment, risk evaluation, remediation techniques, specific applications such as recording incidents and reporting incidents, statistics, metrics, and standards. That's going to be a big battle about standards, as you can understand. We don't have to understand. And this is an example of how we make risk assessment. Briefly, technology. We have used an open source platform, which is Liferay, a horizontal portal in Java, which has a relational database, but also a non-hierarchical database, and a search engine in Java. I hope this very quick presentation allows for some sort of perspective, plan of intervention among different NREs, because, I mean, if we want to develop infrastructure and services, we have to be careful about attacks and cyber warfare, which is unfortunately present. Thank you.
Yeah, Mr. Mazin Qumsiyeh.
Thank you very much. Thanks for the invitation, and thanks for, I met so many of you already, and I'm looking forward to meet many others as we go along and maybe develop some collaborations. What I'm talking about today is basically issues of research, education, and conservation, environmental conservation in developing countries in context of a networked global ecosystem. As you know, the UN had released some goals for 2030, including things like thriving lives and livelihoods, sustainable food security, sustainable water security, universal clean energy, healthy and productive ecosystems, and good governance and sustainable societies. The Universal Declaration of Human Rights further says that everyone has the right to freely share in scientific advancements and benefits. We in the Arab world development goals have actually fallen behind some of these lofty ideals, and we're trying to catch up, and this conference is a very excellent step in that direction, and what ASR and EM does. Now, I want to take a case study of Palestine, even though, as you know, Palestine is not an easy case to discuss. But Palestine, we are also lucky in being part of the Fertile Crescent, where humans first developed agriculture. Also lucky in being basically a crossroad of civilizations and a crossroads of migrations of people and of animals and so forth. For example, over 500 million birds pass through Palestine, annual migrations between Eurasia and Africa. In terms of civilizations, as you know, the Fertile Crescent was the first cradle of civilization, if you want. That's where our ancestors, Canaanites, and before that, the Natufian agriculture, were the first to domesticate animals and plants and live in communities that are in relative harmony with nature, and also invent things like the alphabet that we use. Even the English alphabet, the Latin alphabet, comes from our part of the world as a modification of that. This heritage that we inherited, which we are very lucky to be part of this Arab world and the heritage of the Arab world, is a very rich heritage, cultural heritage, natural heritage, linguistic heritage, and many other areas. But it's all threatened by various things, from colonialism, of course, to climate change, to population growth, habitat and environmental destruction, and so on. I don't want to talk too much about that. You already know these threats and discuss them regularly in very many meetings and so forth. So what is a small part of the solution? It goes back to the issue of thinking globally and acting locally. How do we think globally and how do we act locally with the limitations that we have? So in Palestine we do have many limitations, including the Israeli colonialism that have ethnically cleansed most of our people, etc. One method I thought of, and with a group of volunteers, we established this Palestine Museum of Natural History and Palestine Institute of Biodiversity and Sustainability at Bethlehem University. My wife, who is here, and I donated $250,000 to Bethlehem University to get this started. And we put research as number one priority. And the reason for that, if you look at this table, this is from a paper that I published in 2012 with Dr. Jad Ishaq on the status of research and development in our region and in Palestine. And we obviously have a huge deficit in terms of research for many, many reasons, which again, I don't have time to go through them. But how do we take this picture and change it? And how do we improve our research productivity, basically? And the museum, as I'll show you, and the facility that we set up, now publishes about 2 papers a month. Since we were founded in late 2014, we published 25 peer-reviewed articles. But our research is very much directed to human interest and human activities and and basically applied research, if you want. For example, we studied the impact of the Israeli colonialism on biodiversity. Here is, for example, you can see this hill, which was forested in 1997, and what it became, what it looked like today. And so we showed decline in vertebrate biodiversity in this area. We studied, for example, the effects, genotoxic effects. My background is also medical genetics, so I was able to supervise students to do some work like Khalil, who studied genotoxic effect of Israeli industrial settlements on human populations and so forth. We study, of course, biodiversity like reptiles and amphibians. Many of these studies are done by volunteers and with very, very minimal resources, and I'll come back to that in a minute and how we have done it. Even freshmen in our university, Bethlehem University, like Mohammad is a first-year freshman, first year in biology, undergraduate, and was able to publish this paper on butterflies, and later was able to publish another paper on grasshoppers on his second year, and now is on his third and fourth year, published 2 more papers. So by the time he finishes his bachelor degree, he will have 5 publications, which is better than some of the assistant professors in our university. We do this through students, supervising students. The museum also publishes on use of museums and institutes like this in protection of the environment and ecosystem services, in development and agriculture, for example, permaculture, aquaculture, etc. We also study Israeli mega projects and their impact on the human environment. As you know, for example, the Israeli government has started with a major project that diverted the water of the Jordan Valley, basically resulting in desertification of the Jordan Valley. Now, supposedly to fix this problem with the unfortunate support of Jordan, they started a new project that will connect the Red Sea to the Dead Sea, and this will be environmentally very devastating to the Wadi Araba and other areas, and also saddle Jordan with a huge amount of debt, now estimated $15 billion for this canal. The success, as I said, of doing this also depends on doing applied research. So, for example, we do aquaponic research with some colleagues that came from Geneva and did some research on how we do aquaponics in Palestine, in a developing country with very limited resources. We can grow our own vegetables and our own fish, etc. Because Israel took most of our land and most of our water. So having limited water and limited land, we can do a lot of things, even having our bee colonies, etc. We work with the ministries, of course, like Ministry of Health and Environmental Health and Ministry of Agriculture on permaculture, other things. We depend a lot on international volunteers who come from around the world. So far, over 25 countries that sent us volunteers to Palestine to work with us, to build with us, to do things with us. Our education is basically hands-on for the children, and so we encourage people to get involved by touching and feeling and learning to think, critical thinking, not rogue memorization. In our world, we have a lot of rogue memorization in schools, so we try to change them from that. We take students to the field and we show them the areas, and they enjoy loving nature, loving Palestine. So our keys to success basically is that it's a bottom-up approach that depended mostly on volunteer efforts. Second is that it's collaboration, local and international, and we don't have a single paper, research paper that's single author. They always have multiple authors. Leverage students, undergraduate and graduate students, local and international, focus on the needs of the people, and respect for ourselves, for our co-peers, and for the environment, and the maximum use of IT. And I won't go through the issue of IT too much because I don't have too much time. But if you put in scholar.google.com words like Israel biodiversity, Palestine biodiversity, you can see a huge difference in terms of publications and so forth. We are going to catch up, and we are catching up with the world. There is now a lot of databases that allow us to do significantly more with very limited resources. For example, the Global Biodiversity Information Facility, or earthobservations.org and geoportal.org that give us a lot of resources. Symbiota, LinkedIn, ResearchGates, academia.edu, ORCID, etc. And these give us huge amounts of abilities to reach out to a very large audience and also bring in collaborators in various areas. We so far have many collaborations, especially with Europeans and US and Australian universities. These things help us a lot. The other thing is digitization of information. My son actually invented this vacuum cleaner operated book scanner, and you can put a book on it and it'll generate a PDF file for it. This costs less than $1,500 to make with the software and hardware for it. And now he's improving it, and it helps us digitize a lot of books and have a lot of these things. So our library is becoming mostly digital, and we have tens of thousands of PDF files of various things. Our exhibits are in development, and our botanical garden is in development, and you can see the botanical gardens in the Arab world are very limited. This map shows how much paucity of botanical gardens there are. So we are developing a botanical garden, and we have a design of a museum that will develop. We're looking for funding for this, but we have many applications of this. We have already opened the museum April of this year, and then we have botanical garden, and then we will have on stage 3 building, the green building, to open in April 2019. And we will develop this Palestine Institute of Biodiversity and Sustainability to offer bachelor and master and maybe even in the future PhD degrees. Biospheres and infospheres are connected basically, and we are trying to think outside the box, as I say, in terms of how to connect these things and how to emphasize diversity in the biosphere and diversity in the infosphere. And so final recommendations is to use IT, network, collaborate, innovate, and motivate. And thank you very much for listening, and I'm looking forward to meet many of you and hopefully develop collaborations. Thank you.
Thank you very much, Mazin, for this interesting presentation. I was not following up the time. I gave you extra 2 minutes without realizing. Any question?
Thank you.
Now